Awesome. Thank you, George. Yeah, no, great to be here. Appreciate you all having me on. So today, going to talk a little bit about, what I'm going to talk about is route optimization within Neo4j. And what is Neo4j if you all have not familiarized yourself with? Well, we're a graph database. And to quickly introduce myself, my name is Michael Ryan. I'm a field engineer at Neo. I've been here about 2 years now, and so I'm located in Dallas, Texas, so not too far from y'all down in Austin. And so my background is in operations research, which, if you're not familiar, it's very close to data science. And so I've spent some time in that field doing. We worked at a small company. I worked at AT&T coming straight out of college. Then went to a 5-person startup. So I switched it up big time from going from like a 300,000 person company to a 5-person company. At that company, I did a lot of different roles, but one of the roles I was in, or one of the hats I wore, was doing our data science predictions around sales and marketing analytics. And so a lot of also consulting projects for data science and machine learning projects. And previously spent time at Redis in a similar role that I am in today, but now I'm at Neo. And so like graph databases, because it takes a lot of kind of like operations research kind of foundations, and then also applies a database to it and a very analytical workload. And so before I go into the route optimization notebook, I'm going to describe what a graph is just real briefly. This is like kind of like a quick peer into what a graph database is, the different items that you will see within a graph database, and kind of spark some thoughts on how you could potentially use a graph database. So just talk about agenda. I'm going to talk about, again, mention what is Neo4j. I'm going to give a quick problem definition of the problem statement. Look, it's just a one-line blurb of what we're trying to do, what we're trying to accomplish. This was a demo I gave to a customer talking about to kind of mimic truck driving routes. Figured a quick way, easy way to show that would be with the route optimization, because we can fly straight path, bird's eye view, very simple to do the difference or the distance between the spots. Then I'll go into the demo. I'll show you what the Aura DB instance looks like, and then just a little bit more info. So going into what is a graph? What is a graph database? What do we mean when we talk about graphs? So we're all familiar with these pictures here. We're not talking about this. We are talking about a database that allows us to answer kind of this question here. How do people think, explain, design, and model? When you're approached with a question of how do I find the shortest path for this airport to this airport to this airport, what is the first thing I typically do when trying to solve that? And it's I try to visualize it. If I'm trying to picture how do I fly from DFW to Toronto, Amsterdam, and Houston in the quickest amount of time, and the least amount of legs, the lowest cost, I start drawing it out, kind of like the picture behind me. I start drawing something out to get me there. And so a lot of us, I spend a lot of time in the relational database world, looking at the typical table and column structure, which is completely fine for a lot of problems, or a lot of different, tasks at hand. But really, there's a problem with it in some respect when trying to do things quickly and trying to get people to see the information that you're conveying. And also just trying to make it flexible is you have to define that structure ahead of time. All right, this image here is something I saw a lot, mainly when I was using like Power BI and stuff. Drawing those maps out was an absolute headache. But you have to define the structure ahead of time. If I want to add something, I got to add more information to a table. I have to add a column. I have to have those kind of jammed into those table information jammed into the tables. So that's another problem with that as well, along with being able to link that. So when you design it, it's kind of stuck with that one size fits all table at design. Then also you don't really understand how things are tied. I have table 1, 2, 3, table 5, 4, 54, 80. How do I determine those tables are tied together? We'll have to have a primary key. I have to know what my primary key, I have to know what the foreign key is. I have to know that they actually tie together. What happens when data doesn't exist within those two tables? So now I have to think about that as well. And so relationships technically really aren't real. They're more of implied by joins done through the SQL queries, which I imagine a lot of us here have experienced that and have done those. And hey, probably a lot of us are good at SQL, and SQL is great in a lot of ways. Not saying that it's bad at all, but there are some problems when trying to look at your data model in a more real manner. So within a database, here's just an example. We're going to talk about what, we've seen this view before. What's within a database? I have people within there. A lot of things are common, such as ID, name, address, gender, date of birth. Those are going to be common to all the people within our database. Every single one of our users may have this information. Well, what happens when we throw some new things in there, such as a Twitter ID, if they're married or not, if they had a child. And so these are some things that may not be common to all. And a lot of times when we're looking at that, and that's kind of what I was mentioning, if you want to add more information, you have to add another column. When I was doing data science projects, I would have many columns because I would have Twitter IDs for some people, for example, and I would have to add a column just for Twitter ID. A lot of those would be null, and I'd have to kind of just disregard those, and it takes up space, and it takes processing power, because when I want to query all those people who have a Twitter ID, I have to go through each single one of those records. And so that's one of the items that you kind of see. I want to put that out there just because one of the benefits of a graph is not having to abide by this schema. You have a schemaless environment where not everyone has to be the exact same. Not all the people nodes have to be the exact same. And so what do I mean when I say nodes? A person within a graph, we're going to call that just a person within there is going to be a node. And nodes are defined as nouns typically. So like a person, place, or thing. We have a person over here on the left-hand side. We have person and pet. Those are two labels that we have within there. So on the nodes, you give them labels. And here, the first label I'm going to talk about is a person or pet. You can also add a secondary label. So say all my person and pet, they both are located within US. So I can put a secondary label on there, and a secondary label is really leveraged to add another identifier to this for me to query it quickly. So USA, and you can see China here. And now talking about on the nodes, we have properties. So we have different IDs, name, address, gender. We have the information we had in the previous slide, but it's different for these people. Here we don't have to put a Twitter ID as a property here, but we have it here. You do notice that married is true here and unknown here. That's just a schema design. I could put null, and this married would go away here. So when you see circle, think of a person, place, or thing, noun. That will be your node. And then we have relationships within a database. This is going to be just a basic example of how relationships work within a graph database. So each of the relationships are labeled by a name. So a person works at a company, and they link the nodes together. And you can think of these as verbs. So works at, a person owns a company, a person owns a car, a person is located at a place. This company is located at a place as well. You can also reference yourself. So a person, this is the high-level schema view. Person knows a person within a company or within another company. It could be many different people. And then also you can put properties on there. It's kind of like adverbs. So a person is known a person since a certain date. You can put that information within there. You can leverage that in your queries. How many people bought a car between these two dates? And that's something you can leverage there. And then you can also use that. And then what I'm talking about is using those as two-form pattern within your database. So simple graph example. Here's looking at like a supply chain example. We have a couple orders here. Each order has an ID along with a quantity of how many of a product that they're going to order. So we can see that an order ordered a product. This product has an inventory that we can see here. So we have an inventory node tied to this product, 125. And then this product is manufactured at this manufacturer. And the reason I bring this up is because wanting to know, you can see if you add these up, it's 135. I'm going to run out of inventory. So what I'm going to need to do is be able to see downstream, how do I impact, how do I point this order to another inventory with this product, so we can send the people the products that they need. And also some of it's manufacturers as well. If something goes down with the manufacturer, if this gets completely wiped out, how do I mitigate any more risk for my environment to maybe go to a different manufacturer, a different inventory. So that's something to think about. So supply chain is a common use case that we see fairly frequently within Neo4j. And kind of talking about this as well, a little bit more detail. Neo4j is considered schemaless, where, right, we don't have to have this same amount of properties, same kind of designations for each of the nodes. We really don't have to abide by that. We have to fit this graph structure, and we can create it and iterate over it throughout time. And it's very simple and flexible to do so. And data is traversed. So if I were wanting to know which manufacturer had how many orders, I would simply traverse this graph. And yeah, this is pointing towards the manufacturer, but I can traverse it both ways. So I can get information about this manufacturer here with a simple Cipher query, which is our SQL language. It's very similar to SQL, but it's really traversing the graph rather than writing a SQL query. And it's ACID compliant database. And then talked about Cipher as well. So Cipher is our querying language. And then briefly talking about the graph data science library, there's these high-level algorithm families. We're going to be talking about pathfinding, but there's these other ones such as centrality, importance, community detection, similarity, which nodes are similar to each other. Let's say we wanted a risk score on a product that they might go out of inventory. How would I determine that this product would be a high-risk candidate? Well, one example would be using centrality and importance. To be able to point out, hey, let's assign this score. Let's see how many orders are going in, how many orders are going out, how many inventory, how often is the inventory being updated, different information about that will go through the graph. So really, one of the powers of Neo4j is taking what I have on the whiteboard behind me and actually turning it into a reusable database. Something that may look like this. I have a problem with trying to find route optimization. How do I get that drawn on the whiteboard behind me into a graph and that's usable on my computer rather than just theorizing about it? So that's the brief introduction to Neo. I know it kind of flew through that. I'll pause here. I'm going to open up back this. Any questions just about Neo?
So have you done any ontology work with IATA Air Cargo? They have an ontology that they've built.
Yeah, so really the way it works is trying to draw it out, like visualizing the problem, going back to the beginning, taking how you're visualizing the problem and just the problem at hand and trying to draw that out and then be able to put that within here. So you'd have to define a schema. So it'd be like here, company tied to like back before, person works at a company, person owns a car, and then using that schema to be able to model your problem. There's a lot of you'll hear digital twin a lot of times, like supply chain and oil and gas fields. Those are where I hear it a lot. Where you're trying to actually create your supply chain, I guess, system. I take it from a distribution center to a fulfillment center to a customer, trying to actually model that and make a digital twin within your database.
Cool. So, yeah, you're speaking my language in terms of air cargo with that example. There's like one record ontology. There's also other similar ones.
Yeah.
DLTF. So anyway, cool story. So thank you for sharing.
Yeah. Good deal. Any other questions?
What's the limits on size? Like if I have a SQL database that I want to use here, is it the best idea or is it not? And if I have like let's say a huge database like that, so when it's useful, when it's not? Tell me, because I have something.
Yeah. So rule of thumb, really, I'll talk about size after this, but rule of thumb of when a graph is useful is when you have relationships, when you see I'm needing to see that this company is tied or this product is tied to this manufacturer, that could be an expensive SQL join, right? Like I could, if I have a giant table and I need to see manufacturer ABC and all the products that they shipped, that's fine. That might work fairly quickly because you're doing one join. But if you're doing a join manufacturer to product to customer and then a customer location, you're now joining maybe 4 tables, 5 tables, maybe more. That's when you start seeing really big uplift within the graph because those queries come back very quickly. It exists within there already, and the traversals are where it's the power of the graph there. On the size side, I haven't interacted with a graph that has been, I guess, quote unquote, too big. It just really depends on the size of the problem. A lot of times we'll see is when we're putting in SQL data, it's kind of you may, oh yeah, I have this 10 terabyte or like 150 gigabyte SQL or like Oracle database. Doesn't always translate to graph size, like one-to-one comparison, because a lot of times it doesn't take as much space up, and you're not putting in every single value from that database too. You're putting in select items from there. You
Thank
can't.
you. Good answer.
So on the free version, like kind of like the desk, like the experimental version, you can put in, I think, 250,000 nodes, and I think 250,000 relationships or something like that, which is quite a bit. Like this graph I'm gonna show is tiny. It's so small. It's 6,000 nodes and like 67,000 relationships. Cool. Any other questions? Cool. With that, I'll jump into just the problem statement real quick. It's very high level on this slide. I didn't want to go too deep into this, and then kind of like I wanted to focus more on just the high level. We have many airline routes. One of the, I guess, problems at hand, we were working with someone looking at truck drivers, and truck drivers want to maximize their time. They want to get paid for they want to get the most dollar for their time. And they do that by taking certain truck driving routes. But what happens if this trucker wants to drive from here to here to here to here, or here to here to like all these different locations? They want to hit all of these high notch locations and they have X amount of hours. How do they maximize that? So that's a very common operations research problem, is maximize revenue subject to these criteria. So time, the different routes I can take, the different kind of other constraints that you may come across. And so that was kind of motivation for this, and each route may have a different value. For this, I'm looking at airline routes going from, I chose four different routes that people could go to, and just kind of in hopes that someone maybe plug and play with it one day. But find the shortest path there between four routes. And how do I maximize my dollar? Well, there's a cost formula, and I can look at that and maximize it there. So I'm going to stop with this PowerPoint. Then I'm going to go into my notebook. And that. So kind of going into that, let me pull this back up. We're going to walk through a Jupyter notebook on just how I did this. How do I upload it? And before I go into here, I'll show you that schema view called this is the AuraDB console. This is the browser view where I can type in queries. I can type in different cipher statements right here, and it will retrieve the results. So you can see my schema is fairly straightforward. And I have not shared the notebook yet. No, I will share it after. Here I have an airport, flew to another airport. And let's look into the flew to example. Right after I look at this, let me change this to the code so it's easier to read. Every single node in here is going to be an airport, and every relationship is going to be a different route. It's actually a different airline route that I observed. And one of the problems I'm doing is just looking at trying to like optimize that. There's also other ways to look at how do I optimize flight patterns, because I have all these different routes. I didn't put the information in there on the date and time, but trying to maximize how people fly in, how they fly out. So that's another thought too with this. So you can see all the different airports and who flew to where. This flew to this one. There's a lot of airport codes in here I don't recognize because a lot of very small airports, whether in the States or elsewhere. So this is the browser view. We'll come back into this, but I'm going to go into the notebook, which will be more or less interacting with that browser setting. So I have two different CSVs in here. I have a route CSV and an airport CSV. Really, the routes has the different routes that are taken. The airports is just a giant lump sum of the 6,000 airports. The goal is to minimize it based off of time constraint. You can change your cost formula. So on here, we have a distance. This is 161 miles between the two. This is going to be my cost. This is going to be like the actual cost value for this. You can put whatever, you actually can create your own cost formula too. That would be like, oh, I want to factor in time or traffic, or this is a more dangerous route. I interned at Frito-Lay, and they would have different routes because values, because hey, I have to drive from the mountains, can't just pay me the same rate as driving from DFW to Atlanta, because that person's going to go faster rather than driving to Vail or Beaver Creek or something. They'll have to go up a mountain, and there's more risk to it just on time, and also the bags going in altitude may pop as well. So that's also a factor you could put in there. But before we go into that, really just some housekeeping items here. Installing the notebook, getting all the different packages to display are imported here. I don't use all of these, but I guess I'm a creature of habit, and a lot of times I put the same packages in here. I'm sure I'm not the only one guilty of that. And so going from there, what I'm going to do is I'm going to connect into my database. So I have my host. This is URL that I get with my database. Then a username and a password so I can log into my database. So I can get within there and interact with it, whether it's pushing data. And this is within the Python connector that we have. So whether I'm pushing data or pulling it, I can go both ways using this Python connector. And as we go down, I'm going to explore some of the data, different columns I'm interested in adding within my database. We can see that I have airline ID, source, different information about different routes. And from here, I'm just doing some EDA just to look at how many routes I have, seeing the shape. So I have like 68,000 at the start. I actually take some out, and you'll see that later here.
Michael, tell them what EDA is, because most people don't know. We have beginners.
EDA is exploratory data analysis, if you're not familiar. So
I don't understand. I can't hear a damn thing.
Can you not hear me?
1 second, someone here.
So EDA, so if you're not familiar, is exploratory data analysis. That is when you look at your data, when you get it, it's kind of like the first step within data science. A lot of times, or some people would prescribe, really just kind of understanding at a high level what's within your data. This notebook's not like a perfect EDA example, I will say, because it's I'm kind of more focused on the graph database side of things, and this data is fairly clean, so I didn't have to get like the quartiles. You basically get statistical information about the information, the data within your data set. So here, going through, just kind of getting a shape, getting different information about it. I'm seeing if there's any nulls, taking different value counts. So looking at the shape of it, I just get the head of it. So this function is getting the top 5 rows. So I can see the structure of the data, make sure it makes sense. Looking at the ID. And then I'm also looking at if there's any NAs or how many stops different people have. This really wasn't used. Counting any NAs. Here we can see source ID, source airport ID had some. Code share had a lot. So that's like, probably won't be using that column there, right? We'll look at, I wasn't going to, but if this was something that may want to be used, I'll look into why that would be. We don't need to go into all the ways to fix something like this, but if there was and I wanted to use this, you could impute values, which basically would be I predict a value for it, for this value compared to other similar items within my database or with my data set. Then we'll go back, see the stops, value counts. The stops, yes, it's a stop or connecting flight. And then looking at the last item here, this is just to describe. This is describing my data. How many unique values do I have? What's the top, the frequency, the mean? If you see NA, it's not applicable because maybe it's a string ID. A lot of these not necessary because I'm looking at ID numbers, and I don't care what the mean, standard deviation, min or max of an ID is. Just more so that there's a lot of unique values or the counts make sense. So I always output the head again just to see, that way I can know what I'm working with as I go scroll down this notebook. And then something I do in here is I want to see all the unique routes together. So for like source and destination. So I append those two. That way I can make sure that this is going to actually work and be a worthwhile data set, because got from Kaggle. And if you're not familiar with Kaggle, Kaggle is a place where you can get many data sets. They have competitions and whatnot. But this is, I just wanted to make sure, sometimes you get crappy data from there. So not mostly, sometimes you do. But sometimes the data sets aren't what you're looking for. And here I wanted to verify that it was what I was looking for. So I put the source and destination just to make sure, hey, Orlando to Atlanta, Atlanta to Orlando. These are our most common flights within our database, or common legs within there. So do have repeat trips. So I want to get, that makes me actually on this line here, I give each flight, each route, a flight ID, just a unique ID that just makes sense to me. It's not really an ID that they haven't been there. That way I can know what which actual value they're unique. So you can see here I added that flight ID, and I just started from 1. So now I want to import the airport's CSV. Here I technically could have gotten the airports from here because I have the source and destination, but there's information within the CSV that I really wanted, such as the actual full name, the latitude and longitude, because I was going to use it for the distance between, because I want to get the shortest path. We also have time zone, so that's something to consider as well when making kind of your flight plans. But we're not going into that really today. We're just doing the shortest path. So I do the same steps here, describe the data, make sure I understand what's in there, different NAs. So city, some don't have cities. This IATA code, I want to just have, they don't have that. I don't want to use it because I want to have the codes within there, make sure it's a valid airport for me to fly to and from. So you can see, it took me down to 6,000, just below 6,100. If I were to scroll back up, I had 7,700 airports. So now I'm down to 6,100. So a good amount didn't have that code. And that code that's like DFW or AUS for my airport code. So now I'm making a new data frame for this, group by source and destination. That way I can get just a simple view of each airport, each unique airport, the lat and long, the airport code. That way I can easily drop the things I don't need and import what I do need into Neo. And then I also made sure I kept the ones that did have the code. And do that here as well, kind of a 2-step process here to get that for the routes. So dropping those with the routes. That way I have a 1-to-1 comparison. So finally, I take the head of it, just get this top 5 values, make sure this makes sense. Hey, I'm on the right path here. Things are looking good. So now one of the things I want to do is calculate the distance. I want to make sure the distance between the lat and the long, and there's a formula that I got from the internet for that. Unfortunately, I made this before ChatGPT was really doing this, or this would have probably been a lot cleaner, quicker. So we're doing it. I'm doing this with kind of chunks of code that took a little bit more effort here. But create a data frame for the source and destination to get the distances between each of those routes. I actually could have done this within Neo. This is not technically a step that I have to do within here, but I could have done this within Neo4j without having. I just wanted to do it here, just have a data frame just for complete sake. So now what I'm doing is I'm looping through this data frame, and by no means not saying I'm like a perfect coder. For more of the data science background, so a lot of my coding practices are kind of scripting, getting things looped in there to get the data sets and data frames that I need to run my workloads. But here, what I'm doing is I'm looping through to create that distance formula. So here's the full distance formula from the point A to point B, in creating that distance. So I'm going to scroll down to that result so we can see that, and then I add it back into the data frame. So I add this back into the routes data frame. So flying from here to here at a distance of 936.3 miles. And so you can see every single route and what the distance was. And I want this because I'm going to add it as a property within my graph. And then also doing a value. So if I wanted, say, the reason I chose 0.7, I'm going to pay my pilots here in this example. Let's say there are cargo people, our cargo workers, or people who are our truck drivers. We're going to pay them a certain value per mile. Here, I just chose 70 as just a random number for us to use. So 70 cents on the mile. So each route, so all of these are available routes. So this data frame is every single available route that a person could take, and then the value that they would get paid. So if I was a pilot and I had a certain amount of time, how would if I looked at this giant data frame of all these different possible routes, how would I pick one that makes the most sense for me? How would I pick one that actually I could go and maximize my time? And so with looking at this, yeah, I could probably get something good, but my operations research mind wants me to optimize this. So what I do is I assume a value 500 miles per hour. That's very fast for an average speed, but want to put a duration within time, with hours here. So different time here. So this allows you to use subject to criteria such as time. So we'll scroll down. So this is our final data frame. So this is our source, destination, our flights that people can take. We have the value, the distance, and the duration that it takes. Right, and I point this out because different flights could take different time. This flight, just because I assume 500 miles per hour, it's not necessarily true, right? We could have some flights that may be 350 miles per hour, and others could be 600. So you might be maximizing your dollar elsewhere by using this duration field. So that is the data frame that I'm going to be using. And now I'm going to show how to load that within Neo. And it's fairly straightforward here. I'm connecting to my database with this GDS call that I did up above. And I take that airport CSV. And what this means is merge. It's like a create, but really it's the same thing here. I'm merging an airport node, and every unique airport code I'm going to put in as a node. And then on the create of those nodes, I'm going to create these properties. So I'm going to have name, city, country, lat, long, and then these line up with the actual CSV values. So I'm going to use that, and then I basically just loop through that to create it. And then I do the same thing for the relationships. So this creates a node when you see the parentheses. I'm going to do the same thing here, but I'm going to grab, what I'm doing is doing a match. It's like a select. So I'm basically selecting any source airport. This is just an alias I'm assigning to this with the source code, and then a destination with the destination code, where those source codes and destination codes align with my CSV. And then I'm going to merge. And what I'm going to do is I'm going to create a relationship between those nodes. And on those nodes, I'm going to have this ID. I'm going to use that flight ID. And on that, so whenever you see the brackets, that's going to be a relationship. So between those, on that relationship, I'm going to create an airline, the ID, the distance, the value, duration, assigned by the CSV there. So finally, we're going to go through, and this part will be fairly not straightforward, but this one will be more kind of high level. I don't expect you all to get this just on the fly here, because it is a little bit more, it's kind of a different topic and a different kind of concept. Within Neo, you can run this graph data science library. And what you do is you run them on what's called a projection. And the projection takes a subgraph or a piece of your graph and puts it in memory. And what that allows us to do is, since it's sitting in memory, it's gonna be a lot quicker. Graphs typically, if you're not sure how many people are familiar with storage, but graph databases sit within disk, SSD, and then within the projection, it sits within memory, so super lightning fast. This projection will sit there. So what I'm doing here is I'm grabbing those airports, the relationships, and put into more or less a subgraph here. And what this subgraph now allows me to do is to run algorithms against it. And that's what I'm doing here. So first, I take a straightforward example. I take DFW to Toronto. I chose 4 random airports, kind of random to other people, not so random to me. But I took DFW to Toronto. What's the quickest path between those two there? And a lot of this is just kind of the way that it's structured for adding the algorithm in here. But I have a source node, a target node, which would be my destination. So source would be source DFW. And then destination would be Toronto, YYZ, and K. So Jens takes the top 5 shortest, and it gives me an information there. And this is more so just for me testing. And what I'm doing is I'm going to yield the information here, and I get this value below. So I get source name DFW, target node name Lester B. Pearson, and then the distance between. And then what this does is gives me all of the legs. What are all of the legs between there? So straight line path, DFW to Toronto. That's the fastest path on the distance. What is the second one would be to, I think this is Detroit. So DFW Detroit to Toronto. And it's actually not that much different. Which one is interesting is here we have DFW to FWA, DTW to Toronto. We have 4 legs, or I guess 3 legs, compared to the 2 below, which goes to St. Louis. Which is a little slower here. So this is a quick, easy way to see one flight, one to one, like one target or source to one target. So I can see what it does. I'm going to go to the graph here and show you what actually this is looking at. So this is what we're looking at here. We have our source and destination. And if I were to scroll in here, I'm able to actually see the paths. So I can see path 1. So I start at path 0, DFW to Toronto. Path 1, DFW Detroit to Toronto. Path 2 to Indianapolis. And then we have this kind of middle stop within Fort Wayne to Detroit. And then we have this final one where it's to St. Louis. So I can leverage the information on here for me to actually get the information or like the actual solution, but then also see it in an image, something actually a picture to show people. And is that the shortest path? I'm not actually sure. I don't actually believe you. Here you can actually fact check it, see, yeah, no, it is. We can add these up and we can very much see that path 1 1198 compared to path 4, if I were to sum these, would get me a different value. Yeah, Don, you have a question?
Yeah, what part were you caching now that you have this backed up?
So I wasn't caching anything really per se. I was more so just putting a projection. So I was putting all of the airport nodes and one relationship between the airports to each other. So instead of having where we had before, where I had a bunch of instead of having like 2 relationships here, because these are all of the routes, I have one single route. And it's the minimum, it's the shortest one between those 2, which is the same for all of them.
Great answer. Thank you.
Yeah. So that's for one. If I were to go now, what I want to do is, I'm going to scroll down just because I know we covered this. So you can do duration. So looking at duration, actually look up. This one is doing, yep, sorry, we just covered that one. So if I want to do duration, I can change my source. I can change the relationship weight. Here I still have distance here, but what I would do is just change this to duration, and now I'd be able to see what was the actual value here. So scroll down because I know kind of limited on time here. I'm going to go to where we have a list, because that's where that's where the value is in my head if I were going to want to optimize this. So I have 3 additional three airports that I want to hit. I want to hit Houston, Toronto, Amsterdam. I threw Amsterdam in there just because I went there a couple summers ago, and I figured it'd be fun to throw one way out there. Let's throw one that's a big outlier, so I can actually see the value here. And I do some items here just to see possible values. So adding in DFW, Houston, Toronto, Amsterdam. What are all the possible ways I could order this? And this is what this block of code is doing. That way I can pass it to my algorithm, and so I can loop through these possible groups here. Then kind of have to go an extra step to go get the adjacent pairs, because I have to have a source and a target. So I have DFW to Houston, Houston to Toronto, Toronto to Amsterdam. So I do that for each single block here. So these are all the different orders that I could go. You can see I went DFW to Toronto, Houston, Amsterdam. So now what I'm doing is I'm getting all the source and destination pairs. Then this is kind of the fun part. I loop through to get all of the shortest paths between all of those. And really what that takes is just looping through each single kind of pair, key value pair there, or the 2 values. So I put the source. So basically what I'm doing is I'm putting DFW in here, Houston in here, running that. Then I put Houston in here, and then Toronto in here, and then running that. And then I'm appending that information within there, and I'm going through each of those possible orders of those airports. So then I put that into a data frame. And for that, so I'm adding that information within a data frame there, because I want to find the quickest path. I want to find the fastest, the most efficient way for me to optimize my time. So this is really just this is just making some manipulations on that data frame for us to understand it. But the end value is here. The end value is this. And so if I was the pilot and I was trying to maximize my time, if I was trying to find the quickest path, I would use this table here. And I would have this total distance. So if I were to this total distance, you can see this is the fastest path between those airports. DFW to Houston, Houston to Toronto, then Toronto to Amsterdam. I don't count the return flight, just count the end time. The return flight would definitely be something to add in here, because that is a factor. Because I have to have maybe a dead leg, or maybe there's no route for me. Maybe there's not anything for me to ship back from Amsterdam to Dallas, but there might be something for me to ship back from Toronto to Dallas. So if I wanted to maximize my dollars, that would be the way to do it. So having some kind of operations center would be something like you could add in here. For the total value here, I'm doing it by optimization, but you could do the inverse and maximize it. So I can maximize this to by total value. But let's say if I were to use this table and I have 15 hours. So what I could do, this total duration's not sorted, it's sorted by the distance. But if I only had 15 hours, yeah, I would take this because I know it's 4 hours more, but I get paid $1,500 more, almost $2,000 more because of value here. Or if I had 18 hours, if I wanted to hop up, I could get $6,300 by taking this route and using this. So yeah, that's really the power of the graph there on using the shortest path. Really bring this up to show you what the Aura database looks like. I can run queries within here. So I can grab, I'm just going to go up. So I can grab the different airports. So what this is doing is give me an airport that flew to another airport where my first airport is DFW and the second airport is with the United States. And I'm limited to 25. So I can see all the different airports and all the routes that DFW went to within the United States here. So this is what you do within the browser. You can also run the graph data science workloads in here too. But this is how you would connect. This notebook here is how you would connect into your database. So I'll pause there. That really concludes my part of the talk. Any questions from y'all? I'd love to hear what y'all's thoughts are.
First of all, we want to give you a round of applause. So everyone, please make noise or whatever.
Thank you.
If you have questions, keep them short. So someone who wanted the first, several people raised their hands. So it's interesting for them. Keep them short because Michael has to leave soon. So
I can stick around for questions.
okay.
Yeah. So yeah, if anyone wants, I think I saw Inuit was the first one.
Go ahead. Ask your question. Unmute yourself or put it in the chat and read it. Oh, I think they replaced it with the clap button.
Fair enough. Fair enough.
Come on. Someone did have a question, I believe. If not, I'll ask one because I have something. So you were changing between multiple, like two screens. One of them were the graphs. One was the notebook. How exactly? Can you show us the connection? How it's made? So you talk to the correct graph and so on. It's somewhere in the beginning.
Yep. So part of my scrolling, I'm going to scroll back up to the top. So this is the block to connect in there. And so you saw that I had GDS dot graph data science. This is what I'm calling here. So I'm importing this library from us. It's the Neo4j library. And what this is doing is I give a host. So when you create a database, whether it's on your computer, which would be local hosts, or on a machine, which would be with your IP address. Here we have a URL. So you're using this URL to connect in, and then you need to authenticate yourself. So you have a username and password. And then really whenever you call this, so it's GDS dot graph data science, it's calling this function to log in.
So this is the connection to Neo4j. Okay.
Yep.
Thank you. Yep. You might want to change the password later because
so that's not the real password. So
good.
Yeah.
Okay, Matthew wants to ask a question. Matthew, ask a question, please. Unmute yourself.
Yeah, I also typed it into the chat, but In terms of speed of operations in a graph database, what operations have the quickest performance, I guess is the way to put it.
Yeah. So I'll give kind of the most, I guess, generic answer for that. It really depends. But to talk about that and what I mean by it depends what you're trying to do. What query am I trying to do? If I'm trying to query all the airports, so you saw my query here. If I'm trying to query all the airports within the United States, I went through and I went to a property. So I went to the United States and grabbed a property there. If I had, how we saw in the PowerPoint, a secondary label that was United States, and instead of doing airport, I did USA, I had to say a secondary label on here, this would perform quicker than doing the property here. Reason being, I now just filter down to airports that have the secondary label, and it knows that very quickly. By me doing the property method or way, I have to go through every single airport, drill down. Okay, click on this one. Okay, United States is here. All right, United States, check. Boston, United States, check. I get Amsterdam, not. I see that it's not US. And so I skip that one, but I still have to drill down to that node. So that's that's kind of one method that we think about when we're designing our schema. And the source of the data, see the chat there, Don. Haven't uploaded the notebook yet. I will send it out. So Jacob, I'll send the notebook to you. And then the data before was just simply in CSVs. Got it from Kaggle, CSV format. Very straightforward, very similar to SQL structure, but that was the format there. So grab it online.
You have an online link for this demo, or will I have to post it somewhere?
I can make a GitHub repo for it if that's the ideal way.
If you don't have to, but otherwise I'll make it, so it doesn't matter. So it's
I'll throw one up there.
Okay, so send me a link then, and I'll make sure that it is posted afterwards. You don't have to stay for this. We can do it offline later, and I'll post it on the Meetup page, and if anyone needs it, send me an email later.
Awesome.
And now the question's coming. They are keeping you here. Go ahead.
Yeah, it's a quick question relating to training. I think, what is it, Graph University or something? Just looking for some good tutorials on how to load things like OWL, databases, etc. into Neo4j.
Yeah, I mean, Graph Academy is a great place to start, just to get the basics of Cypher and understand how it works. Because within there, right within my notebook, it really is, with Python, going through here and understanding how these are, how to formulate this. It will teach you how to do this, and then how to upload CSVs, which a lot of relational databases, right, their structure is a CSV essentially, and you can actually export those to blob storage and go from there. There's a lot of, and I hate to say it, but which is fine, but ChatGPT is kind of good. So don't feel like you're it will get you kind of to the spot where you can get some good information out of there.
Alrighty, and if I don't like ChatGPT's answer, I can always go to Claude. So there you go.
Yeah, and you can feel free to shoot me a message as well if you have questions about it. Happy to answer.
Excellent, great session.
If you have time for one more question, I see Chilibwe is asking, if I'm pronouncing the name right. You will ask a question, please.
Yes, this is my first time here. Question for you. I'm trying to actually build up a system for a studio. I mean, for my own studio. And just make the question small. For your airport simulation, your airport basically database, is there any way to make a GUI? I mean, where's the path to where I can make a GUI of that? So you can have you can connect airport to airport. You can connect airport to anywhere else on the planet. You know, what is the pathway to have that that option?
Yeah. So, you know, it works a lot like any other database.
Right.
So you would really just create what I have. Like if you're going to use this example that I had here today and you wanted to create a front end with it,
Right.
you could use React. Use React and that would work fine. Actually, that'd probably be the one I'd go to. I've been meaning, it's been on my list for a little bit to create a React app with this, but you really just interact with your database how you would for other applications. So you just use those. It depends how you want to structure it, but yeah.
It would be inside. Well, that's the other reason I also came to this group. I'm wondering, should I just leave this as a freestanding like mini application? Should I put this in something called because I do visual effects and stuff? Should I put this in Houdini, Blender, Max, Maya? And I'm wondering how I could do that. The thing is that I'd have to go on that side because you guys have no attachment to that. I would have to find out how to do it over there to access that database.
It's quite a distance. What Michael suggested is create a web GUI. React.js is a library that helps you do that. There are many other libraries in Python, but you still have to do it yourself.
Right.
Yeah.
Okay.
So let's talk about it later afterwards. Michael just needs to leave, so I'm cutting it short. If it's okay with everyone.
Please, thank you.
Yeah.
Unless someone really has a pressing question, I would like to thank Michael. So anyone, any pressing question? Good. No pressing questions. So, Michael, I apologize for taking a little bit.
I talked longer. I rambled. So
No. But you said that you. So thank you for giving a nice presentation. People like it. You see already people are putting it in the chat. Send me all the material or the links afterwards offline. I know you need to go now. So again, a round of applause for Michael, and we'll end the recording. So
all right, awesome. Thank you all. It was great meeting you all. Great conversation. I enjoyed. It's always fun to talk.
yeah, don't go away. We're not finished. We're just stopping the recording and saying goodbye to Michael. Michael
Michael can go away. Michael has a child now.
All right, see you all.